Excellent. Well, thank you for jumping in. Actually, we're delighted that you've joined us. P3 is probably the best, one of the best analysts, if not the best analyst in the game, looking at the market and the landscape for solid state batteries. I'm delighted that you've joined us, and I'm really happy that you're going to be giving us a market overview and an analysis of the landscape for solid state batteries. So the stage is yours, and good luck. And to the audience, if you want to ask questions, you can still ask the questions on the other platform, and we really want to hear your questions. So I know it's hard to juggle two interfaces, but hopefully you can manage. And yeah, over to you. Thanks.
All right. Thank you for the introduction and thank you for the invite, of course, naturally. So what I'll be presenting today will be the market overview and landscape for solid-state batteries. More specifically, how solid-state batteries fit within your demand roadmaps of OEMs like Volkswagen, Mercedes-Benz, and so forth. And on the supply side, from the cell suppliers, CATL, Samsung, SDI, for example. And within this context as well, we will look at current solid-state battery players, their products, and how they are currently in the development stages and the time to the market within, of course, an automotive context. So, in general, what we are seeing on the demand side is that we are seeing an accelerating increase in demand for battery cells, which is largely driven by automotive sectors. And this large demand from the automotive sector started out due to OEMs having to fulfill compliance targets, CO2 compliance targets. And in order to fulfill these compliance targets, we can actually then calculate or forecast the demand of OEMs for specific years and their strategies towards electrification. So with that in mind, we have an approximation of forecasted values by 2030 based on these electrification environmental targets. They would require at least 3.6 terawatt hours of battery cells. Now, this is the minimal value so as to achieve these targets. However, what we are actually seeing on the other hand is that there could be another value that can be extrapolated. And this value is when we look at, for example, current combustion engine vehicle sales, and we extrapolate and into electrical vehicles. And these are the demand that will be expected if all of the current combustion engine vehicles have similar sales. If electric vehicles have similar sales to current combustion engine vehicles, and they will reach at least around 4.8 terawatt hours, and this is represented by this black dotted line on the figure. Now, in general, we believe that that OEMs, they would not be just targeting this minimal value of 3.6 terawatt hours. We are seeing aggressive strategies, ambitious targets from these OEMs, and we believe that they will be, therefore, the demand from OEMs will lie between the range of the upper limit of around 4.8 terawatt hours and 3.6 terawatt hours. The 3.6 terawatt hours is just the minimum value. Now, these are all in the context of the demand from OEMs. What about on the supply side? When we look at global cell production capacities announcements, for example, what we are actually seeing is that there will be an oversupply, around 7 terawatt hours of cells being produced, but only 4.8 terawatt hours is required by the OEMs. Now, this is, of course, if we take that these values will be ramped up according to the time frame that these facilities, cell manufacturers provide. However, as histories and trends have shown us, is that we will always expect a ramp-up delay. The total cell supply will therefore not be at 7 terawatt hours as forecasted, but around 4.5 to 5 terawatt hours range. And this still shows a slight oversupply, but that is not as drastic as what we have seen if we take the announced scenarios into account. Now, what about solid state technology, and how does it fit into the demand and supply side of this battery market, battery ecosystem? What we are seeing is that from our forecast is that solid state technology, they will contribute a very small fraction of these 4.5 to 5 terawatt hours demand. In fact, it will be around 20